Okay, hope everyone had a lovely weekend. Some of you have been asking when are we going to get to something called pH? Well, today is that day. Okay, so today we're going to be looking at how we calculate, how we find pH from the concentration of H+. It's super easy. And I want to get you all into the right mindset because we're going to be using something called the log function on your calculator. So welcome to log. I'm going to introduce you to one of my favorite cartoon series from when I was a kid. And you are probably not going to enjoy this as much as I did, but this is a cartoon called Ren and Stimpy. And this is their commercial for log. All right, I hope you enjoyed it. And if you didn't, I bet you that some of your folks did. So, welcome to log. It's a function on your calculator. You see it here, right down here. It's the button that says log. All right, I'll show you how it works. So, how we find pH from the concentration of H+. It's a real simple equation. Now, if the circumstances were different, I would explain what pH means. We'll simply say this, that pH is what scientists call the power of hydrogen. It is, of course, the hydrogen that is present when an acid or base does what it does. All right, and when we say power, we mean exponent, but we're not going to work it like that. Here's how we're going to do it. According to the equation, pH is equal to the negative log of the concentration of H+. And that's it. You can get the log function right here on your calculator. The log button is right here next to the 7 button. I'll show you how it works. It's super easy. So let's say that we wanted to find the pH. What is the pH of an acid where the, sorry, that says when, where, sorry, the concentration of H+, remember these brackets, is 1 times 10 to the negative 5 molar. Okay? We're going to plug it right into our calculator. And according to this calculation, the pH is equal to the negative log of the concentration of H+, which in this case is 1 times 10 to the negative 5th. So, bust out your calculator. I'm going to turn mine on, clear it because we want to make sure that we have nothing else. And we are trying to find the negative log. See what I did there? And we're simply going to enter the concentration. 1 times 10 to the negative 5th. We don't even need the close parentheses, but I'll do it so it makes it look like it does here. And I'm going to hit enter. Boom. Ladies and gentlemen, the pH of this particular solution is 5. Now, I know you have all heard of the pH scale before, and what you might have seen back when you were in junior high is that the pH scale is a measure of acid strength, or we might even want to say base strength. If you had a fairly decent science teacher, they would have told you that anything where the pH is less than 7 is an acid, and anything where the pH is greater than 7 is a base. And of course, if anything has a pH that is equal to 7, that is something that we will call neutral. Okay? So let's try a couple of these where we're going to actually use an acid and a base to calculate their pH. Okay? So here's the type of question you could expect me to ask. What is pH of a solution of hydrochloric acid that is 3.4 times 10 to the negative 4th molar? Now, you know it's an acid, all right? You know that its pH should be less than 7. Here's how we're going to do this. I asked you all to practice your dissociation equations for a reason. And you know that HCl, in this case, it is 3.4 times 10 to the negative 4th molar, has 1 H+. That means when we put it into solution, we know exactly what the concentration of the H+ is. We don't care about that. All right? So we know that the H+ is equal to 3.4 times 10 to the negative 4 molar. What's the pH? It's equal to negative log of the concentration of H+ in solution. Well, you know that. So negative log, in this case, of 3.4 times 10 to the negative 4 molar. Let's bust out our calculator. Isn't this neat? I have my Texas Instruments fancy schmancy graphing calculator right here on my computer. So we're going to say negative. You're going to hit the log button right here next to the 7, and you're going to enter your concentration, 3.4 times 10 to the negative 4. You don't even need the closed parentheses. Boom! There, ladies and gentlemen, is our pH, 3.468. You could round that to 3.47. Heck, you could even write it to 3.5, which follows dead in the same way that acids are acids. They should have a pH of less than 7. Let's do one where we're going to do it with a base. Okay, here is a typical base. We know it dissociates into sodium hydroxide. Excuse me. We know that sodium hydroxide dissociates into sodium and hydroxide. So here's a question. What is the pH of a, let's use the same value that we had here, 3.4 times 10 to the negative 4, times 10 to the negative 4 molar sodium hydroxide solution? Okay, so we know that sodium hydroxide looks like this, and this is what it does when it dissociates. I know I wrote it up there, but I don't mind being redundant. Here is 3.4 times 10 to the minus 4 molar sodium hydroxide, and we know it's going to dissociate into both of these, and we're only worried about the hydroxide. 3.4 times 10 to the negative 4. All right. Well, we want to plug it into our equation to find pH. It's equal to the negative log of the concentration of H+. But we don't have that. This is a base. How are we going to find H+ when it's a base which produces OH-? All the way back to the beginning of chapter 15, where we know that Kw, which is always equal to 1 times 10 to the minus 14th, is equal to the concentration of H+ times the concentration of OH-. That means that H+ is equal to Kw, which is 1 times 10 to the minus 14th, divided by OH-. So let's find it. 1 times 10 to the minus 14th is Kw. You know OH- because you found it right up there. 3.4 times 10 to the negative 4 molar. Let's bust out our calculator. We'll say 1 times 10 to the negative 14th divided by 3.4 times 10 to the negative 4. Here's our concentration of H+, 2.94 times 10 to the minus 11th. 2.94 times 10 to the minus 11th. That's our H+. Let's plug it right into our equation. Negative log of H+, which you just found, 2.94 times 10 to the minus 11th. We'll say negative log of our answer. I'll be fancy and use the answer button. Boom! I don't trust that. Still getting used to this. Let's just pop it in, and let's just pop it in regular. 2.94 times 10 to the times 10 to the minus 11th. Our pH is 10.53, which falls right in line. Sorry, I'm trying to write here. 10.53. Dead on the money for what we expect for a base. A base should have a pH that is greater than 7. All right. That's all you do, ladies and gentlemen. So hopefully you are going to use log. Everyone wants the log. It's better than bad. It's good. All right. Give it a try.